Hello, my name's Carl Irwin, and I am testing out an OpenGL tutorial. You can see that what we're going to look at here is a video that I recently posted on my YouTube channel. You can see it's a video of this Ferrari pulling up in this parking lot. Apparently it's at probably a dark night time type scene in this parking lot, and this Ferrari pulls up from the background into the foreground and parks itself right here. A lot of things going on. You can see that it's the render has some motion blur when the vehicle is moving. We have these lens flare elements that are on there. There's also some atmospheric effects. There's some lens grit you can see illuminated by the lens flare. You can see also that there's lighting is casting off light that is appearing to exist in 3D space. We also have some shadow going on here, and the model itself has a number of details that are rendered on it, and this is rendered entirely using OpenGL rendering capability in Blender, and the advantage to using OpenGL over something else, and there are only a few advantages, and really the big advantage is time. Rendering OpenGL in any program platform is considerably quicker and faster than rendering using a traditional render engine, and of course there is a trade-off with that. You lose detail, you use material and texture capabilities, but I found that, and a lot of other compositing platforms are finding that using OpenGL as a render platform can be very useful in that you can get fairly passable results on single elements that you might use for compositing. Now, you probably wouldn't want to render an entire scene with all three-dimensional objects in OpenGL. It would be probably give a very plastic kind of appearance to it. But when you're just rendering one element, like just this one vehicle, for example, and some of the things surrounding it that are affected by the vehicle's presence, you can get away with it. It doesn't look too bad, and probably with some more time spent on compositing, this could be made to look even more realistic than it is right now. Clearly, it's not completely realistic. There are some things that you can point out that are somewhat flawed, but you know, it's pretty passable if you're making a low-budget film or just a commercial or something like that, something was under low scrutiny, this would work out pretty good. So let's take a quick look at the project. You can see here I've got, this is the Blender project. And if you look at the 3D viewport, you can see this is what the Opengl output looks like. And it's actually pretty good, pretty passable. This is just a background image set up in the background viewport, and it's a little bit slow here because there's a lot that it's animating, but given that, it's actually moving pretty quickly, considering it's giving a full textured render. And you can see that once we get all the way down to the end, this is what the final output looks like without any compositing at all, and that's not too bad. You can see how quickly this renders at 720 HD. If I render one Opengl frame here, it takes just a couple of seconds, and there you've got your full image, and that is the fully rendered output. Opengl output, pretty powerful, pretty good stuff going on here. So in today's tutorial, I'm going to look at some of the aspects of rendering in this manner. Essentially, this tutorial is about materials and texturing in Glsl shading mode, because that is really what makes Opengl rendering useful in Blender. I'm not going to discuss really at any length the topics of animation, and I'm certainly not going to discuss modeling at all, and I'm not going to discuss really texture mapping or anything like that. We're just going to look at some very general materials and how we apply these materials so that you can see them in the 3D viewport. Now, first of all, it's worth noting that Blender has been able to do this for quite some time. This is not something new, but with the influx of other programs out there and other plugins for other compositing platforms that use Opengl, it might be worth to discuss the fact that Blender is able to do some of these things that you may be seeing other programs do. One comes to mind is an exceptional work of Andrew Kramer at Video Copilot. I reference him a lot because he's an excellent teacher for the After Effects platform, and his company has quite a few exceptional plugins for that platform. I don't use it, but lots of people do. And one of his latest plugins is something called Element 3D, and ever since it came out, the YouTube and Vimeo arenas have been flooded with all of these Element 3D videos that are being made, and Element 3D is really just a 3D is an OpenGL 3D renderer. That's really all it is, and it can function inside of After Effects so that an individual can quickly composite in a 3D model using OpenGL rendering capabilities with some really great features, by the way. Features that perhaps we may not be able to achieve in Blender, but really great features. And anyway, a compositor can achieve this quickly without having to render out full ray traced elements before compositing. They can do it all in one location. So what I wanted to show you is that Blender can actually do essentially can do the same thing, not completely, but there is one way I want you to look at this before I get started. You wouldn't say, and hopefully you follow me on this logic pattern here, you wouldn't say that the only thing wrong with your cat is that it can't bark like a dog. You wouldn't say that. That doesn't make any sense. A cat is a cat, and a dog is a dog. So I'm not going to suggest that the only thing wrong with one platform in terms of 3D rendering and compositing is that it doesn't do something that another platform does. That really isn't fair. It really doesn't make sense, because each platform does its own thing, and each platform does its own thing differently with its own intent. Blender does do OpenGL, much like other platforms. It doesn't do it necessarily the same way or with the same focus or with the same intent, but it does do OpenGL, and it does do it pretty darn well, as you're going to see here, I think, anyway. And it does it well enough that you can pull off most of the effects that you would want to do in some other platform. That being said, it doesn't do certain things that are featured in Element 3D. Element 3D is made with the intent to use OpenGL rendering with production value. So it's got a lot of hopped up, interesting interesting features that allow it to do that in terms of the way it applies ambient occlusion, fake ambient occlusion, which Blender can do, by the way. It takes a little different kind of tweaking to do it, but it does do it. And integration with other plugins that, of course, Video Copilot makes for After Effects. Element 3D is meant to work with those things. So, again, we're not going to try to make this cat bark like a dog, because it isn't a dog, it's a cat. It does something different. And by the way, you could extend that analogy to just about any other feature that you can use in Blender or any other software. Halo materials comes to mind in Blender. People are always knocking on Halo materials and how it can't do things that other particle simulators can do, and even the particle simulator itself in Blender, and how it's inadequate compared to other things. And that's just ridiculous, because the particle simulator and the Halo texture and the materials that are in Blender do what Blender intends for them to do. And if you want it to look like the output of something else, then, well, you've got to figure out how to make that work using what it can do and what it does do. So enough of that rant. Let's get on with it. So let's look at Opengl rendering in Blender. First thing you need to do is enable Glsl shading. So you've got these three options in the Blender internal render engine. You have to make sure it's set to that first. We're not actually going to use the internal render engine, but that's the only way you can access these items here. I think maybe you can do it from cycles. I'm not sure. It doesn't really matter. We're not going to use either. Usually it's set by default to multi-texture. We want to change it to GLSL because that will enable the Opengl rendering capabilities. Now that you've done that, you can change your viewport shading to texture, and if you give it a second here, it will apply the Opengl view. And this is what you would see if you were using GLSL and the game engine, the render engine that's part of the game engine in Blender. Look very similar to this. Not exactly. There are a few differences, but this is what you get. Now, what we're going to look at very quickly here is just quickly how the scene is set up and how we pull off some of these textures, because when you think of Opengl, usually you think of a gray texture that has a little bit of I don't know, artificial looking kind of shading on it. You don't think of reflection. You don't think of you don't think of I don't know, this this shading, these kind of shadows. You certainly don't think of a shadow being cast from one object to another with this kind of soft definition. Certainly not in Blender or many other OpenGL rendering platforms. You don't think of those things, so we have to find out how we can make these things happen in Blender. So let's quickly take a look at some of these materials. First thing I want to point out is that this is a free model that I got from TurboSquid, and I'm not going to use it for commercial purposes. There is a limitation on it. I'm not going to enable this tutorial for monetary gains, so I shouldn't be breaking any rules there. But it is a free model that you can get. TurboSquid is a really great model sharing platform, and also you can purchase models from there. And this is in the OBJ format, which is very, very compatible with Blender. So let's take a quick look at the materials. If we click on this item, which is listed as a null item, and if we look at the materials that are in here, let me tab out of edit mode real quick. We can go down these on the right hand side, and you can see that there's a bunch of names here, a bunch of materials, and they all, some of them are well labeled and some of them are not, and that's the trouble you run into when you download models from the internet, or if you don't create the model yourself, is that sometimes things aren't labeled well, sometimes they are labeled well. This is kind of in between. Some things are labeled well, some things are not. So the first thing you do is you go through each one of these, because the materials aren't going to be right when you first load it up, most likely. You want to go through each one of these and change the color, to something really crazy, maybe all white or all pink or something, and see what changes on the model so that you can map out what the parts are going to be. So as I'm looking at this, the first thing I probably want to affect is the bodies. So let's click on the body real quick. Car. Well, that's not it. Hang on one second. Let me find it. We'll find it here. Car body. Here it is. Okay, so this is the body. Now you can see that I have a color on here, but it's showing up black. It's not showing up properly in the preview. And I change the color to red. I set the specularity from Cooktor, which is what the default is. It's kind of a soft kind of specularity, to Ward. I'm not sure if that's an ISO. I don't really know what all these mean. Maybe some of you do. But anyway, this one here, Ward, looks like it's ISO or Ward LSO. I'm not sure. This one is more of a specularity shader that would reflect a hard surface. It's very, very stark, and you can change the elements of it by changing the slope. So I select that so that we get kind of the shine and shimmer. And before I go on, let me point out that I placed in my scene, this is just an image set on the background. I placed in the scene some lights. These are just plain OpenGL lights, placed approximately where there might be some lights in the scene. You can see two obvious ones there. I placed one kind of in the background, and there's a few that are placed up in the foreground that you can't see. And that's just to emulate the general lighting of the scene as it appears to be in the photograph. Anyway, so we set this to Ward ISO, and again you can see that our texture is not showing up, and that's because I'm using the node editor, and I'm using nodes to set up this material. And the way you do that is you click on the this button here. It says use shader nodes to render the material. Now you would use this if you wanted to use nodes to work on materials in the internal render engine, but you know, surprise, surprise, it also works for OpenGL. You can use nodes to do that. So let's do this real quick. We're going to open up a node editor and take a look at how this material was put together. And here we go. Let's zoom in. This is the whole material right here. So the first thing first, before we go to the nodes, I have a couple of things set up in the texture slots for this material, and really just one thing. What I did is I added a texture on top of my color. If you go to your texture slot, which is the image in the background, and I'm going to use this for reflection. So what I did is I opened this image and I apply it coordinates as a reflection, and then I set the color, of course, to 1, so I'm getting all of it, and then I use the transfer mode, the blend mode, add, and what this will do is it will add all of the colors that are lighter than my red to the image in a reflective pattern. Okay, so as the model moves around the scene, I will get a reflection based on this image, which very closely resembles the environment that the vehicle is in, and all of the colors that are lighter than my red will show up, and everything that is darker will not be applied. which is very, very, very similar to how real specularity, real reflective lighting, and real reflection would work in a real world setting. Okay, so right away I have a really good reflective material just by applying this one technique, by placing this image in the texture slot and applying it as a reflective texture. Okay, so now back to the material. We're going to enable the nodes. So I've got my material in here. Now the second issue we're going to deal with is that we don't have any kind of ambient occlusion. Now, ambient occlusion is a fancy word for more shadows. Okay, ambient occlusion is just a form of shadow that occurs as two items converge on each other, and it becomes more difficult the closer you get to the apex of those two objects meeting, like the corner of a room, for ambient light to bounce into the crevices, and it creates shadow, a soft shadow. So we cannot create that soft shadow in Blender OpenGL using any kind of real lighting. We have to fake it. So there's an easy way to do this. So what we do is, if you go to the Vertex Paint mode, and if you select on Paint next to it, the Paint option, you can click on this item, Dirty Vertex Colors, and what it will create is something that looks like this. Let me connect it over here and you can see. It will create something that looks like this, and you can see my model now has crevices that are either illuminated or darkened, and you can see some parts of it are shaded properly. What it does is it paints darkness into areas where the vertices converge on each other. It guesses at where there should be some kind of ambient occlusion, and it will paint that on there. But you notice there's some places where it looks good, like right here on this line, and some places where it's completely wrong, like here around the door. It's brighter. It should be darker. That's okay. We're going to work with that. Anyway, what you do is you create this image, this mapped image, by using the Dirty Vertex Colors. You might have to hit it a few times. And what we're going to do is we're going to go to our node editor, and we're going to add a geometry node, and we're going to use this output vertex color, which is this that we've created. Now what I've done is I've mapped it into an RGB curve, and I'll show you what's going on here. And I set the contrast to be inverted. So now I've got these dark edges and very light color anywhere I don't want to see the shadowing. Okay. Now what happens is I lose some of the other spots that were mapped properly, but we're going to take care of that. Okay. So now I've got all these crevices, and what I do is I apply over here this output, this contrasted output, to a mix node as the factor, and above I use a black color that I'm going to use for my shadow, and underneath I use my material output, and when I apply this as the factor, I get something that looks like this. Okay, so you can see now I have this creviced shadowing. Now some of these places where I had good shadow before, it's not there, and that's because my mapping was wrong. That's okay. We're gonna deal with that. So what I did next is I created another RGB curve that has the opposite type contrast, and that one looks like this. And I applied this to the Vertex color. So this has the opposite. This has the shadows that were good, but it doesn't maintain the shadows that we just retained in our first contrast curve. Okay. Now what I'm going to do is I'm going to apply this one to another mix node, and I'm going to put a black color on top again, and I'm going to take the output from the first mix node with the good shadows, and I'm going to apply that underneath, and I'm going to use this RGB curves output as the factor, and then what I'm doing is I'm mixing together both of these applications, and I end up getting all of the shadows that I want, okay, from both sides. So that's a trick to use your Vertex Paint, dirty Vertex Paint output. Even when it's not perfect, you can mix them together to get all of the shadows that you intend. And this is a way to do it. So now I've got ambient occlusion that otherwise does not exist in OpenGL shading. There's no way to do it otherwise, but I can fake it using this technique on models that are well created. Again, this only works with models that are made well, and this is a really well made model. Okay, so that's the body color. Now all of the body material. Now the good news is that all of the other materials that I use, I didn't really need to do this. I could have applied ambient occlusion, this option, to the tires, but I didn't bother. I got it on the big parts of the car, and if you wanted to be really picky, you could do that. You could apply it to every little piece of the car that might have this kind of situation. I just did the big parts to get this to get this test out to you. So now you go through the other items, and you want to identify what they are, what the materials are, and then apply your shading. So for the windows, again, I applied the same reflective material to a black color, so it looks tinted. And here I apply this material, and I set it to add again, so it adds all the lighter colors, and it gives a really believable reflective material. So this is essentially how you achieve all of the good looking textures. Is you can use the nodes, and you can just use the material slots inside of the Blender internal render engine options to achieve this, and then apply it in the Glsl mode. So let's take another look at this very quickly from the camera viewpoint. Now, in order to render this as it is, we can go to the display options and click on only render, and it will render everything that we see without any extra selection lines or anything like that. And to render the output, I just click on this button down here. These are your Opengl render buttons. This is for single frame, and this is for animation. And the animation button will follow all of the parameters that you set up in your render output for the internal render engine. Most of them, anyway. So if I click on single frame, you can see it renders in just a couple of seconds, and here we've got this output with all of our ambient occlusion, our reflection, and our light shading that we have applied, and this already looks really good. Now, the one thing you might be looking at that looks a little confusing is the shadow that's underneath, and you might be wondering how in the world was that pulled off. Very simply, what this is it's an image. It's just an image plane. And if I go to my world settings, and if I change the world setting to a white color, you have to forgive the slowness of this because I am running a screencast, and you know, we are rendering an Opengl, and it is quick, but it is still having to process quite a bit here in the 3D viewport. So this will pop up to a white color, and we'll be able to see what's going on here a little bit better. Maybe. I guess while I'm waiting for this, I'll just explain what's going on. Underneath, oh, here we go. Underneath this is a plane, and the plane, if I select it here, let me slide it out of the way, it is a painted shadow, alpha transparent enabled painted shadow. And what I did is I took a still image of this car from the underside or from the top side, it doesn't really matter, brought it into GIMP, darkened it to black, turned up the contrast and darkened it down, and then I applied a blur, a Gaussian blur to it, and then I took 4 circular masks and I placed them where the wheels would be, and I applied a more subtle blur to that, and I came up with this image, which is a shadow that matches the vehicle, and then I position it underneath the vehicle, and I parent it to the vehicle so that it travels with it as I set my animation. Now, this is how you have to do it. Now, before you get too worked up that this seems like it's, takes a lot of work, you have to do this in Element 3D too. Even in Video Copilot's Element 3D. Now, I know that they're going to remedy that and apply a type of a shadow renderer. But this is how OpenGL works. You have to fake everything. You have to, a lot of things are incredibly artificial. I mean, it's all artificial, but you can't just use OpenGL lights to cast shadows that look like this. You can use sun lamps in Blender to get hard shadows, but to get the soft shadow, you have to create these extra assets. Now, rendering transparency in OpenGL can get a little funny in Blender. It doesn't always work very well. If you have more than one item that has transparency, you have to create them in a certain order and depth in order to see through one to the next without getting distortion. I'm not going to talk at great length about that. All I'm going to say is that if you're only using one image and you're not placing this image over top of something else in a scene, you won't have any trouble when you go to render. You'll see all of the multiple bit support for your transparency, your alpha channel. Okay, so that's how that is achieved. And in the next part, we're going to take a look at how some of this is composited together and rendered together, especially the lens flares. I have a number of tutorials on my channel about lens flare, but we're going to look how I applied the lens flare options in here and some of the color correction. Before we start looking at compositing situations and compositing methods, I wanted to take a minute to point out one other feature that I didn't cover in the video that I made. I have played around with this idea in Blender, but I didn't do it on this video, and I just want to show you something you can do with the materials that's kind of interesting. I'm not sure if you've ever heard of the term Chroma Flare. Chroma Flare is a type of paint that will give off, or a type of pigment that will give off different colors at different angles, and when different light sources pass over it. So here are a few Google images that you can take a look at that are examples of Chroma Paint. It's often used in the automotive industry for hot rods and the like, flashy cars, and you can see some of these vehicles. At one angle, the paint appears to be one color, and then a different color at a slightly different angle, and then another angle changes color again, and the way light bounces off of it changes the color of the paint. And you can actually do this in Blender, actually, and there's a few ways to do it. One way, the easiest way that I found, is to create images that images that look like this. Here is a material that I have on here, and you can see that there is a red center to it, and then the outside edge is kind of an orange color, and the way you apply this, you can apply it as a texture and set the color all the way up to 1. The influence, the diffuse influence, up to 1, and apply it the coordinates as normal rather than as generated, but as normal. And what it will do is the closer the center that you get on this texture, that color will be applied to the faces that are facing directly towards you, the normals that are facing your point of view. And then as the normals start to point other directions until you get to a perpendicular facing, it will start to apply kind of this gradient out to the other color, the outside color. So let's try this one. We'll turn this one on, and this will replace the red color that's on there. And I'm not sure if you can see it really well, but once you apply this, you can see that the color changes, and the closer you get to the perpendicular faces, the more orange the tone is. And you would be surprised at how much more realism is added by adding something like this. And this is a very mild case of it, a mild instance of it. A more aggressive instance might be something that looks more like this. This is an image that these are images I created in GIMP. Again, it's just a flat plane, just this flat image, two-dimensional image, with a gradient from the center working out towards the edge, and then applied using the normal mapping. So here you can see is much better instance of at least more aggressive instance of it. The flat surfaces facing the point of view are more of a blue color, and the further away you get from that head-on view, the more purple, until you get to the perpendicular planes, which are green. And you can see, if I scrub through the animation here, as the vehicle moves, so does that color, as the angles of the vehicle change from our point of view. So, really interesting kind of concept, and it can add. It's a pretty sophisticated kind of material, or a pretty sophisticated application of material. And you could apply this in some more subtle ways or more aggressive ways, however you please. But it's just something that I thought would be worth pointing out. You can also use this kind of to mimic subsurface scattering in a way. One of the excuse me, one of the elements of subsurface scattering, that is the light bouncing around through the inside of a texture, a translucent or slightly opaque type texture, is that the angle of the texture changes because light passes more readily through thinner parts of the texture. And say if you had a sphere with and it had a subsurface scattering type effect applied to it in a traditional render engine, the center of that sphere would have a different color, or slightly different color, different texture than say the outside of the sphere, which might catch more light and have a lighter tone to it. And you can mimic this to a certain degree based on the combination of a normal mapping texture in this manner, and also the combination of specularity, lower specularity helps that kind of effect a lot more too. So you can actually cheat a lot of these other more complex texturing techniques in OpenGL if you think really carefully about what you want to accomplish and try to be innovative and clever. You can actually get away with a lot. So anyway, just wanted to point that out, kind of a more advanced texturing trick that you can use in OpenGL. And if we render this, do one frame of this, you can see it looks pretty good. You know, if we had some color correction and compositing, this might look quite interesting. It might look pretty realistic. So anyway, that's just a trick that I have discovered in the course of using OpenGL. Let's turn this off. We don't need it. And go back to our red color. Okay. Now, compositing. One of the first things I want to point out is that rendering in OpenGL it does not give us the option to use motion blur. We cannot use sampled motion blur. Now we could render out our pass in OpenGL and then apply that pass in the compositor and apply a vector blur a pass to it to add the motion blur. But you know that vector blur does not work all that well all the time, and the best kind of motion blur is a sampled motion blur, and that does not work. All the settings that are in the Blender internal settings over here work for our output in terms of file format and file location where we're sending our file to render. All that stuff applies. Frame rate applies. All that applies. But some of the more advanced settings do not apply. In particular, sampled motion blur does not work. So we have to find another way to get motion blur. And the way I found to do this is to generate more samples. And I talk about this on another tutorial on my channel, and I'm not going to talk at great length about it because you can just check that out. But essentially what you want to do is just increase your number of samples and still render out the same animation, just with many more frames to work with. So what you can do is change your end frame to another number, a much higher number. If we just double it from 250 to 500, and then we're going to change our time remapping. You can do this one of two ways. I could change the new number to 200, doubling it, like we doubled our end frame, or I could change the beginning mapping to 50. We could cut it in half. Now what will happen is if I go to the end of the animation, you'll see that it ends at 250 on the timeline, but there's actually 500 frames between 0 and 250 in terms of the number of frames that it will render. From here, I can render out this pass, and what I want to do so that I can separate the background from the foreground in compositing, you could, by the way, render this as we've been doing in our single frames. You could render this just using the background image, but we don't want to do that. We want to separate the background from the foreground. So what I would do is render just one instance of this background, or just use the original background image in our composite later. And over here, I'm going to set my alpha, instead of to sky, I'm going to set it to transparent. And this will apply to even our Opengl output. And down here, I'm going to turn on RGBA, so red, green, blue, and alpha channels, and I'm going to make sure it's set to PNG, and then I'll create a folder, and I will output my render frames to that folder. And what it will do is it will render alpha enabled frames, so that we'll have our car, we'll have the shadow under the car, and then we'll have alpha transparency behind it, and I can use that pass then later on in compositing. So let's take a look at compositing very quickly, and I'm just going to brush through this very quickly. If you want to learn more about compositing in the video sequence editor, you can look at some of my other tutorials, especially concerning lens flares. I'll talk briefly about lens flare in this, but if you want to learn more about that, I invite you to read some of the other, or rather view some of the other tutorials I have. Let's very quickly go to the video editor, video sequence editor, and here I have my output already created, and let me explain what I've done here. Let me put this back to the right frame output. This is the final animation, and if I scrub through, you can see that it moves along, and there's alpha transparency. What I'm going to do is I'm going to enable this bottom texture, this bottom
layer that I put on here that gives us a background pattern so you can see everything a little bit better. If I scrub through this, you'll see that what we have is motion blur. You can see that as the vehicle is moving, there is blur in the motion that it is moving. And this is achieved with our oversampling that we have used in our render output. And what I did was let me disable this for a second. In fact, I'm going to delete the speed modifier that I placed on there. Erase that. And I'm going to expand this out, show you what I did. Unmeta strip. Whoops. Strip. Unmeta strip. And what I have here is 1, 2, 3, 4, 5 instances of my render output. And the first one is set at frame 0. The second one is slid over 1 frame. The next one is slid over another frame, and then another frame, and another frame. And each one of these instances has a lower and lower opacity. And when they all stack up, we create the essence of motion blur. And you can see how these interact with each other to create that kind of effect. And then what I do, let me undo here. What I do is I create these, I consolidate these into a meta strip. And the meta strip is just a consolidation of many different strips into one new strip, and it just makes it easier for you to color correct and add various further effects to. And I find that it's easier to deal with this effect by creating a meta strip. And you do that by coming down to the strip option down here and select make meta strip. And then on top of that, because this is 500 frames long, on top of that I add a speed effect. And the way you do that is you select your meta strip, go to strip, I'm sorry, go to add effect strip and add a speed control. And then you change your speed control settings. You want to click use as speed, and you're going to change the speed factor to 2, so it's going to play back twice as fast, thereby condensing 500 frames into 250. And what you get is you get a 250 frame animation, just like we originally intended. However, we get all of these sampled, oversampled samples stacked on top of each other, creating our motion blur. So this is really kind of the long way around creating a motion blur. It's really the same process that sampled motion blur goes through. It's just that we're doing it intentionally and manually. Now you might be thinking that, well, that's a lot of trouble to go through. Well, I promise you that with the render time that you're saving using OpenGL, it really doesn't take that much time at all. You're going to find that you render out the 500 frame output very, very quickly, because it's only a couple of seconds per frame, just a second per frame if you have other things on your operating system turned off and you're just running Blender. And then it's a very, very short period of time to wait for that, and then putting this together only takes maybe a minute to get all this set up. Now at this point, what we're going to do is we're going to render this back out again. So what I would do is I would have my top layer set, my speed output set to alpha over, and I would just disable the opacity on my meta strips. So all I'm outputting is my speed control output here, which has the motion blur in it. So I would output this to another set of another folder as PNG format files with alpha transparency enabled, and I would output it at the regular frame rate, 100 to 100 and 250 frames. And now I've got my composite layer that I can work with. So we take this then to another layer, which I put on another scene, and you can see here's my final output, and now it's 250 frames with that motion blur. This is what I can use to work with now. Okay, so again, I've got my layer underneath here just to show you the transparency. I'm going to turn that off, and what I'm going to turn on, I have another layer on here, which is the garage scene. So now we're back to where we were at before with the 3D viewport, which again you could render straight if you wanted to, but I'm choosing to do it separately so that I can color correct each element. Now from here, what you can do is you can do a little bit of color correction to match these a little bit better. So you can change in the video sequence editor. You can change the properties of your clips in a lot of different ways. You can change the saturation. I turn the saturation down on the car a little bit, just so it's a little desaturated to match my environment. I added a color curve to it. You can do the same with your background plate. I didn't really change anything on that. And then what I did is I output this again as an AVI video file. So this is my base animation. If you wanted to, you could stop right there. This looks pretty good already, the way it is. But I want to add a few more effects to this. So I output this as a video file, and I can use that then later on for further compositing, or for a later step. So let's go to another scene. This is the next scene that I have, where I've put all of this out, and this is my video that I rendered out from the previous scene. But now you can see I've got some other elements on here. I've got some lens flare effects going on. There is a vignette applied here. You can see the color correction, major color correction applied to the whole output. And I'm going to go through each one of these things kind of individually, so you can understand the process that was used to get to this point. So first thing, let's talk quickly about just the basic lens flares that are being used. So there are lens flares applied to these lights up here, and then I have lens flares in the car. Let's take the lights first. What I did is I created a scene, and I think it actually might be this scene. Let me go back to the default view. I created a scene with a couple of alpha transparent enabled images that have light rays positioned where these lights would be. And let me see here. Let's try scene 2. Here they are. And you can see that these are just image planes, and they're positioned over where these lights would be. And all I need to do is I can use this scene output. I don't need to render this separate. Okay, so this is scene 2. So if I go back to my video sequence editor, what I did is I placed scene 2. I clicked on add, and I added scene 2, and I set it to add. The transfer mode is set to, or the blend mode is set to add. So it's adding these light rays onto my background plate that I rendered from the previous scene. And I can tweak this here in terms of color correction and in terms of contrast to get this light ray overlay and put everything more into a 3D space. So these light rays, even though the light source exists behind the vehicle, the light rays are projected in front of the vehicle, which is more realistic in terms of what a lens flare would do. It would be in the lens, and therefore the rays would exist on top of all of the objects within the scene. Okay, so that's the first one. Now we're going to apply the exact same kind of process to these lens flare elements that are on the headlights. And the way I did that is I had another two other scenes. I did a separate scene for each one of these lens flares, and we'll take a look at that very, very quickly. So scene 3 is the first one, and what's going on here is I have this lens flare, which is just an image that I composited together using various elements that I created using halos and Blender, and also using a GIMP just to put these images together. And I created this image plane of a lens flare, and none of the elements move. This is all just a single image. And again, I have other tutorials on my channel that you can check out concerning more complex scenarios using lens flares in this way. But I'm just going to use this one. Now, what I did in this case is I parented this lens flare to the car by selecting a vertice on the vehicle. And let me turn the vehicle mesh on very quickly here. I selected a vertice in the center of that headlight. You can see here's the vehicle, and I parented this plane, this image plane, to that point, and then I added to the image plane a constraint, a rotation constraint, and I set that rotation constraint to keep X, Y, and Z parallel to the camera. So wherever the vehicle moves in the animation, that image plane will stay parallel to my camera. And then it's a simple matter of animating the size of my image plane for the points whenever the light becomes occluded. So I determined that around frame 159 to frame 200, because the vehicle turns, the light source becomes more occluded behind the casing of the headlight, therefore making the light source, hiding the light source away. So that means that the lens flare would decrease in size. So I just scaled it, put a couple of keyframes in here, and I scaled my lens flare down to that point where the car stops. Okay, and let me turn off the car, and I did that again in another scene for the other headlights. Same kind of process, and I won't turn the car on, but essentially it's the same thing. And this one, the way the car turns at the end, it actually completely occludes that headlight. So the flare diminishes to 0, and I just set that scaling. Okay, so this is my lens flare. Now, when I add this scene to my composite, we won't see this background image. We'll just see this flare on black, and I can set that transfer mode or that blend mode to add. So let's go back to scene 2 where we're compositing everything together. Excuse me. Go to the video sequence editor, and we can see here this is the final output. So that plus a vignette image that I put on there, and then some final color correction. Also, you might notice that in here there is a little bit of lens grit that shows up. And what I did for that is I rendered out very quickly just these lens flares in a video output very quickly, just those two lens flare elements I rendered out, and then I ran it through the Blender Compositor, and I added a very heavy fast Gaussian blur to it, and I created a mask that I can use then to affect a lens grit image. And again, I'm not going to get into depth on that particular technique. You can check some of my other tutorials to see how that's done, my other lens flare tutorials. But that in a nutshell is how I composite all the elements together and how they work. And again, most of these elements, except for the car and the background, which are a separate video element that I rendered separately, all of this stuff is live. All of this is occurring in separate scenes, and then they're composited together in the video sequence editor, and then color corrected and put together. So that's how I put the scene together, and these are some tips that you might find good use for, and hopefully you got some information you were not aware of, or never were able to experiment with, and hopefully this helps you on some of your projects Vertex in terms of rendering very, very fast assets using the Opengl output in Blender. So I hope that this was a useful tutorial, and I wish all of you happy blending.